In 5.1 we solved with graphing, but in 5.2 we're going to solve using substitution. Over here I'm going to sketch a graph in red so you won't have to. And to introduce this idea we're going to start easy. So in order for it to be a system of equation, you wouldn't have just one equation, you would have to have two equations. So the two that I'm going to have you write down on the left will be x equals 5. And even as simple as that is, it's not just telling you that x is 5. This does have an equal sign, so it is an equation. And then for the second equation, we'll say that y is 2x plus 1. Over on my graph, I can sketch the graph of x equals 5 here. And then for my other line, I can sketch the graph of 2x plus 1. So that means that this system of equations, 2x plus 1 down there, these will run into each other at some point. So they'll have one solution for this setup. And we won't worry about the infinite and no solution setups for now. But I know that if you've written down these two equations, the chances are they will have one single solution. To make this value of x stand out, I'm going to trace blue over that black 5. And then in the other equation, I'm going to trace over the value of x. And the reason this is called substitution is because you are literally substituting in the value of x, which is 5, into another equation. And the reason you do that is because right now I have two equations, so there's E, Q, and S, with two variables. And whenever I had two equations and two variables, I can usually reduce this down to 1 and 1. So right now y has x in there, which means that the second guy has one equation and two variables, so there's an infinite number of points on this line. But when I substitute 5 in for x, I'm going to skip a line. I'm going to write 2 times 5 so you can see that I'm substituting in this value of 5 for that x. And I'm going to add on 1. 2 times 5 gives me 10, plus 1 gives me 11. And then just like with graphing, when I go ahead and I summarize this, I would say x is equal to 5, 11. And I'm calling this starting easy because I think it's clear that you can see the purpose of substitution here. You're just taking a value for x and plugging it in with the goal of turning an equation that has two variables into something that only would have one, which was y. So let's see this in a little bit more complicated type of problems. Here we have 5 separate problems, some that will eventually have fractions. I'm going to zoom in after reading the directions, and we're told to use substitution to solve each system of equations. In the next section, you'll be taught another way of doing this. Now, as we do these bookwork problems, you always want to rewrite both of them. Y equals 3x, x plus 2y equals negative 21. I'm going to move up so we can see this more clearly. And then you can ask yourself, well, what would be easier? Would it be easier to try to get this to where x was by itself and then y was over here and then you'd substitute it in over there? Well, you can just draw. You can see my lines and find out that that's kind of challenging. Would it be difficult to get y by itself so I could then plug y in up here? I think that would be a lot of work. But when I look at this, the easiest way to go about it is, since y is already by itself on one side, I know that y has 3 and x. So if y is equal to 3x, if I were to take 3x and substitute it in for this y, I would only have x and then something else with x, which I could then solve. But right now I can't really solve either of these as they are. I'm going to trace over this value of y in green so you can see what I'm going to do. And I always skip a line here. And the reason I skip the line is so that I can see that I'm dealing with these two equations originally. So for the substituting step, I'm taking the second equation. I'm just starring it so you can see it a little bit. I'm going to write x plus 2 times, but then I'm going to substitute 3x in there. Now I don't have any negatives or anything, but I think it'll be nice to see this in parentheses so that we can clearly see what y became. And then I'll finish writing the rest of the equation equals negative 21. Earlier, I had two variables and only one equation in the part that I've circled, and now I have only one equation with one variable, which means I can figure out a definite answer for x. Here's x plus 6x equaling negative 21, and then I simplify, and then eventually solve what's turning into a one-step equation. Now your work isn't done, and the reason your work isn't done is because you've only found x. You still need to find y. Now this means that I can take x and substitute it in here or there. And as you look at this, you can probably figure out that plugging it in for 3 times negative 3 is going to require the least amount of work. So on this other side, using the same exact row that I started with, I'm going to write y equals 3, so I'm getting this from up here, times a negative 3, which means that y is negative 9. And when I summarize my answer, x comma y is going to be negative 3, negative 9. Now, it's not enough to check this in just one of these equations. If I want to make sure I'm accurate, I would need to check it in both of them. When I check it here, 3 times a negative 3 does give me a negative 9. So it works in the first equation. And then here when I plug in negative 3, and I'm writing this in red because the goal is to do as much of this in your head as possible. Here I am plugging in the values, and if I did negative 3 plus 2 times negative 9, that's the same as negative 3 minus 18, and that does give me negative 21. So our answer checks out in both of these. All right, let's summarize what happened here. I knew what y was in terms of x at the start of the problem. That meant that I could easily plug in 3x for this value of y. Once I did that, it meant that I could come up with an equation that only had one variable. So by substituting one variable, one equation means that you can solve for a definite answer. And then I use that to plug into the easiest of the two equations to find out what y would be. And finally, we would summarize x comma y because this would be an ordered pair. It would be a coordinate in space. And so having done that, the only other thing we could do is check it in both of our equations. We'll stop this video here since it's approaching 10 minutes. And the next video will focus on doing a couple of these on your own, as well as some that'll be guided in these notes.